An interstellar object passes through our solar system, and instead of just tracking its orbit, scientists quietly point some of Earth's most sensitive radio telescopes directly at it to ask a harder question. Could this thing be artificial? This video explores why that question was taken seriously, how scientists tested it without speculation, and what the outcome of that search reveals. The decision to scan 3i Atlas for artificial signals did not come from social media hype or sci-fi curiosity. It came from a convergence of specific measurable factors that pushed this object beyond routine classification. The first key point is that 3i Atlas was not treated as mysterious, but as statistically unusual within the small but growing sample of interstellar visitors. Unlike earlier objects, its detection window allowed scientists to observe its trajectory and behavior early enough to plan targeted follow-up studies. Its inbound velocity, hyperbolic path, and orientation relative to the solar system were all consistent with an extrasolar origin. But what mattered more was how predictable those parameters were. Predictability made it testable. That is a critical distinction because science does not investigate anomalies because they are strange. It investigates them because they can be constrained. This is where the debate sharpened. A small but vocal group of researchers argued that when an object is both interstellar and observationally accessible, the cost of not checking for artificial signals is higher than the cost of checking and finding nothing. Among those voices was Avi Loeb, who has repeatedly emphasized that dismissing possibilities without data is unscientific, even when those possibilities are uncomfortable. What made this moment different from previous speculation was restraint. There were no claims that 3i Atlas was artificial, only that its characteristics justified a narrow, controlled test. The scientific threshold here was not belief, but methodological responsibility. If humanity is serious about detecting technological intelligence beyond Earth, then interstellar objects passing through our own backyard are the closest thing we get to a natural experiment. This matters because it reframes the narrative. The scan was not triggered by imagination, but by process. 3i Atlas crossed a line where curiosity became obligation. And once that line is crossed, science does not speculate. It measures. That measurement leads directly to the next question. If you were going to test for artificial origin, how would you do it without fooling yourself? Once the decision was made to look for artificial signals, the challenge became execution. Searching for technology is not the same as searching for life, and this distinction defines the entire methodology. The scan of 3i Atlas was carried out under the framework of Breakthrough Listen, one of the most rigorous and conservative efforts ever designed to detect extraterrestrial technology. The core idea behind this approach is simple. Advanced technology, even unintentionally, produces radio emissions that differ from natural astrophysical processes. These signals are typically narrow-band, structured, and repeatable. Nature, by contrast, tends to be noisy, broadband, and chaotic. The scan targeted these differences, not hypothetical messages. To do this, researchers used the Green Bank telescope, a facility capable of detecting extremely faint radio emissions across a wide frequency range. Crucially, the observation strategy included controls. Scientists did not just point the telescope at 3i Atlas and wait. They also observed nearby regions of space to identify and subtract background interference, including Earth-based radio noise and satellite contamination. The data pipeline was intentionally unforgiving. Candidate signals were flagged automatically, cross-checked against known interference databases, and then reobserved to test persistence. Any signal that failed reproducibility was discarded. This matters because false positives are the biggest enemy of technosignature research, and the system is designed to eliminate excitement, not encourage it. What's important here is what scientists didn't do. They didn't assume intent. They didn't look for patterns that felt artificial. They didn't stretch definitions to keep the mystery alive. Instead, they asked a narrow question. Does this object emit radio signals inconsistent with known natural processes? The answer would come from method, not belief. And once that method ran its course, the result, whatever it was, would carry weight. Because a null result obtained this way is not a failure. It is a boundary, and boundaries are how science moves forward. The result of the scan was clear. No credible artificial radio signals were detected from 3I Atlas. At first glance, that might sound like the end of the story, but scientifically, it is the most informative part. The absence of technosignatures does not mean the scan was pointless. It means the hypothesis was tested and constrained. Scientists can now say with confidence that if 3I Atlas were emitting radio signals consistent with known technological processes within the observed frequency range and sensitivity limits, those signals would have been detected. They weren't. This immediately strengthens the interpretation of 3I Atlas as a natural interstellar object, likely a comet-like body shaped by processes outside our solar system. Importantly, this conclusion is not based on assumption, but on elimination. Artificial origin was not dismissed. It was examined and ruled out within defined parameters. There is also a deeper lesson here about expectations. Many people assume that searching for extraterrestrial intelligence means hoping for a yes. In reality, science advances through disciplined no answers. Each null detection refines our models, improves our tools, and sharpens future searches. Silence is data. This outcome also establishes a precedent. Interstellar objects are no longer just curiosities to catalog. They are now targets for systematic technosignature screening. The infrastructure, protocols, and decision-making framework used for 3I Atlas can be reused and improved for the next object that enters our system. Perhaps most importantly, this moment demonstrates scientific maturity. Extraordinary questions were handled without sensationalism, using transparent methods and public data. That builds trust, not just in the conclusion, but in the process itself. By ruling out one possibility carefully, science cleared the path to focus on what truly matters. Understanding how often interstellar material visits our solar system, what it carries with it, and how future instruments might expand the search beyond radio signals altogether. That leads us to the broader meaning of this event. So the most important result from scanning 3I Atlas wasn't a message, a pattern, or a surprise transmission. It was restraint. Scientists asked a difficult question, tested it with precision, and accepted the answer without forcing a story onto it. Interstellar objects are no longer just visitors we watch from a distance. They're probes from other star systems carrying clues shaped long before our solar system existed. This time, the answer was silence. Next time, the question will be sharper, the tools better, and the expectations more grounded. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel keep exploring the universe with depth and curiosity. Now, we'd love to hear from you. What do you think this result tells us about how scientists should investigate future interstellar visitors? Share your thoughts in the comments. Thank you for watching, and see you next time.